Generally, heating, air conditioning and refrigeration rated circuit breakers are needed for air conditioning and refrigeration systems. This is noted in the National Electrical Code section 440.22 subsections A and B. Subsection addresses motor compressors, stating that circuit breakers for motor compressor circuits need to be horsepower rated and listed for motor compressor applications. Subsection B addresses resistor start motors, specifying that circuit breakers for resistor start motors must be horsepower rated and listed for resistor start motor applications. However, there are exceptions. If the unit's nameplate explicitly says that a heating, air conditioning and refrigeration rated circuit breaker is not needed, or if the unit is permanently connected to the branch circuit conductors and the branch circuit is protected by a listed circuit breaker or fuses that are rated appropriately for the unit, then an exception applies. Fuses can be used instead of heating, air conditioning and refrigeration circuit breakers, provided they are listed for motor compressor applications and have the correct interrupting rating. The National Electrical Code references heating, air conditioning and refrigeration breakers in several sections, including 430.32 subsection A concerning panel boards for motor circuits and the requirement for heating, air conditioning and refrigeration circuit breakers when used with hermetic refrigerant motor compressors. National Electrical Code section 440.22 focuses on motors and motor controllers on refrigerating and air conditioning equipment. National Electrical Code section 440.52 discusses cable tray installations for air conditioning and refrigeration equipment. National Electrical Code section 550.14 covers theaters, amphitheaters, and assembly halls. National Electrical Code section 551.34 relates to swimming pools, hot tubs, and spas. It is important to consult the specific edition of the National Electrical Code being used, as section numbers can change between editions. When selecting a circuit breaker for air conditioning or refrigeration equipment, firstly, check the equipment nameplate for specific requirements or exceptions regarding heating, air conditioning and refrigeration rated breakers. Secondly, if a heating, air conditioning and refrigeration rated breaker is required, ensure the selected breaker is horsepower rated and listed for motor compressor applications. Thirdly, if fuses are used instead of circuit breakers, verify they are listed for motor compressor applications and have the appropriate interrupting rating. Fourthly, consult National Electrical Code sections 430.32 subsection A, 440.22, 440.52, 550.14, and 551.34 for specific requirements related to heating, air conditioning and refrigeration breakers in different applications. Fifthly, ensure that all electrical work is performed by qualified personnel who are familiar with the National Electrical Code and local electrical codes. Sixthly, always prioritize safety when working with electrical equipment, and follow all applicable safety procedures. Seventhly, when in doubt, consult with a licensed electrical engineer or inspector to ensure compliance with all applicable codes and standards. Eighthly, remember that the National Electrical Code is a minimum standard, and local codes may have additional requirements. Ninthly, keep accurate records of all electrical work performed, including the ratings of circuit breakers and fuses. Tenthly, regularly inspect electrical equipment and wiring for signs of damage or wear. Ensuring the proper selection and installation of circuit breakers and fuses for air conditioning and refrigeration equipment is critical for safety and code compliance. Always refer to the equipment nameplate, the National Electrical Code, and local electrical codes for specific requirements. When working with electrical systems, always prioritize safety and consult with qualified professionals when needed. Always verify local amendments or variations to the National Electrical Code. These can be more stringent or specific to your region. For instance, some areas might have specific requirements regarding arc fault circuit interrupters, often referred to as FSIs, or ground fault circuit interrupters, often called GFCIs, in conjunction with heating, air conditioning and refrigeration equipment. Understand the difference between inverse time circuit breakers and instantaneous trip circuit breakers. Heating, air conditioning and refrigeration applications generally require inverse time breakers which allow for short duration overloads like motor starting currents without tripping. Instantaneous trip breakers are designed for immediate response to high fault currents. Pay attention to the ambient temperature rating of circuit breakers. Circuit breakers are designed to operate within a specific temperature range. High ambient temperatures can affect their performance and cause them to trip prematurely. For critical applications, consider using circuit breakers with adjustable trip settings. This allows you to fine-tune the breaker's response to overloads and short circuits, optimizing its performance for the specific application. Before installing any electrical equipment, perform a load calculation to ensure that the existing electrical system can handle the additional load. This calculation should take into account the continuous and non-continuous loads on the circuit. Regularly inspect and test circuit breakers to ensure they are functioning correctly. Over time, breakers can become worn or damaged, which can compromise their ability to protect the circuit. Use appropriate conductor sizes for all electrical wiring. Undersized conductors can overheat and cause a fire. The National Electrical Code Table 310.15 provides guidance on conductor ampacity. Ensure that all electrical connections are tight and secure. Loose connections can cause arcing, which can also lead to a fire. When working with electrical equipment, always wear appropriate personal protective equipment, often abbreviated as PPE, including safety glasses, gloves, and insulated tools. Never work on live electrical circuits unless absolutely necessary. If you must work on a live circuit, use extreme caution and follow all applicable safety procedures. Develop and implement a comprehensive electrical safety program. This program should include regular training for employees on electrical safety procedures. Keep electrical panels clean and free of obstructions. This will help to ensure that the breakers can be easily accessed in an emergency. Properly label all circuit breakers. This will help to prevent confusion and make it easier to identify the correct breaker in an emergency. Use surge protection devices, often called SPD, to protect sensitive electronic equipment from voltage surges. Voltage surges can damage or destroy electronic equipment. Consider using power quality monitoring equipment to track the performance of your electrical system. This equipment can help to identify potential problems before they cause a failure. Consult with a qualified electrical contractor for assistance with any electrical work. Electrical work can be dangerous, and it is important to have it done by someone who is properly trained and experienced. Remember that the National Electrical Code is constantly evolving. It is important to stay up to date on the latest changes to the code to ensure that your electrical installations are safe and compliant. The National Fire Protection Association, commonly known as NFPA, offers a variety of resources to help you stay informed about the National Electrical Code. These resources include training courses, publications, and online forums. Consider subscribing to an electrical industry publication to stay informed about the latest news and trends in the electrical industry. There are many excellent publications available, both online and in print. Attend electrical industry conferences and trade shows to network with other professionals and learn about new products and technologies. These events can be a valuable resource for staying up to date on the latest developments in the electrical industry. Get involved in your local electrical industry association. These associations provide a forum for electrical professionals to network, share information, and advocate for the industry. Support efforts to improve electrical safety. Electrical safety is everyone's responsibility. By working together, we can make our homes and workplaces safer. When dealing with motor compressors, understand the concept of lopped rotor amps, often shortened to LRA. This is the current drawn by the motor when it is first started. Circuit breakers must be able to handle this high inrush current without tripping. Be aware of the different types of motor starters available. Reduced voltage starters can be used to reduce the inrush current when starting a motor. Ensure that the motor starter is properly sized for the motor. An undersized starter can overheat and fail. Regularly inspect motor windings for signs of insulation breakdown. Insulation breakdown can lead to short circuits and motor failure. Consider using thermal overload relays to protect motors from overheating. Thermal overload relays will trip the circuit breaker if the motor gets too hot. Properly ventilate motor rooms to prevent overheating. Overheating can shorten the life of the motor. Use appropriate grounding techniques for all electrical equipment. Grounding helps to protect against electric shock. Ensure that the grounding system is properly installed and maintained. Regularly test the grounding system to ensure that it is functioning properly. The National Electrical Code Section 250 provides guidance on grounding requirements. Be aware of the different types of electrical hazards. Electrical hazards include electric shock, arc flash, and arc blast. Follow safe work practices to avoid electrical hazards. To energize circuits before working on them whenever possible. Use lockout-tagout procedures to prevent accidental energization of circuits. Wear appropriate personal protective equipment when working on electrical equipment. Maintain a safe distance from energized equipment. Use insulated tools when working on electrical equipment. Be aware of the potential for static electricity buildup. Static electricity can damage electronic equipment. Use static control measures to prevent static electricity buildup. Properly dispose of electrical waste. Electrical waste can be hazardous to the environment. Follow all applicable regulations for the disposal of electrical waste. Recycle electrical waste whenever possible. By recycling electrical waste, we can conserve resources and reduce pollution. Support efforts to promote energy efficiency. Energy efficiency helps to reduce our reliance on fossil fuels. Use energy-efficient electrical equipment whenever possible. Properly maintain electrical equipment to ensure that it is operating efficiently. Consider using renewable energy sources, such as solar or wind power. Renewable energy sources can help to reduce our carbon footprint. Promote electrical safety in your community. Teach others about electrical safety. Share your knowledge of electrical safety with others. Work to make your community a safer place. By working together, we can prevent electrical accidents. The electrical industry is constantly changing. Stay up to date on the latest developments in the industry. Attend conferences and trade shows. Read industry publications. Network with other electrical professionals. By staying informed, you can provide the best possible service to your customers. The electrical industry is a rewarding career. If you are interested in a career in the electrical industry, there are many opportunities available. Get the training and education you need. Work hard and be dedicated. You can have a successful career in the electrical industry. Remember that electrical safety is everyone's responsibility. By following safe work practices, we can prevent electrical accidents and make our homes and workplaces safer.